Some of the challenges for data center networking include traffic load balance, support for migrating virtual machines in response to changing demands, adjusting server and traffic placement to save power, provisioning the network when demands fluctuate, and providing various security guarantees, particularly in scenarios that involve multiple tenants. To understand these challenges in a bit more detail, let's take a look at a typical data center topology. A topology typically has three layers: an access layer, which connects the servers themselves, an aggregation layer, which connects the access layer, and then the core. Historically, the core of the network has been connected with layer 3, but increasingly, modern data centers are connected with an entire layer 2 topology. A layer 2 topology makes it easier to perform migration of services from one part of the topology to another, since these services can stay on the same layer 2 network and hence would not need new IP addresses when they moved. It also becomes easier to load balance traffic. On the other hand, a monolithic layer 2 topology makes scaling difficult, since now we have tens of thousands of servers on a single flat topology. In other words, layer 2 addresses are not topological, so the forwarding tables in these switches can't scale as easily because they can't take advantage of the natural hierarchy that exists in the topology. Other problems that exist in this type of topology is that the hierarchy can potentially create single points of failure, and links at the top of the topology, in the core, can become oversubscribed. Modern data center network operators have observed that as you move from the bottom of the hierarchy up towards the core, that the links at the top can carry as much as 200 times as much traffic as the links at the bottom of the hierarchy. So there's a serious capacity mismatch in that the top part of the topology has to carry a whole lot more traffic than the bottom. We'll explore how modern data center network architectures address these various challenges, but let's first take a quick look at one way of solving the scale problem.